Welcome to International Brain Excel School, Chemistry Senior Secondary. Our topic for today is organic chemistry, but under organic chemistry that we shall be looking at representing structures of organic molecules. Alright, I'll be starting with some few carbons, but let me be using one carbon. That's a carbon. The denotation of a carbon in organic chemistry, the prefix is what? Is met. 2 carbon atoms, the denotation is what? Is earth. 3 carbon atom, the denotation is what? Is probe. And so on. In the next class, I'll teach you the prefixes, or in the class. As we are going on in the class, I'll be teaching you all the prefixes. Let's start with 1 carbon atom, met. It's 1 carbon atom. That is 1 carbon. According to electronic configuration of carbon, we have hydrogen, helium, lithium, barium, boron, carbon. So the atomic number of carbon is what? Is 6. So carbon, atomic number is what? Is 6. Let me write it. Carbon is 6. The electronic configuration of carbon is what? 1s2, 2s2, and 2p2. 1, 2, 3. Yeah, 2, 4, 6. That's the electronic configuration of carbon. If we have to look at the shell configuration of these 6, this is electronic configuration. The shell configuration of carbon. The shell configuration. Mind you, if you don't want to call it electronic configuration, you can call it what? Orbital configuration. Shell configuration. That is the KLMNO shell. So the shell configuration of carbon atom number 6 is what? Is 2 and what? And 4. That is K shell can contain maximum number of 2 electrons. This K shell, L shell can contain maximum number of 4 electrons. Alright, so I'm taking you back to electron configuration. Having gotten that, you agree with me that the shell configuration of carbon is what? Is 2 and 4. So if I'm to draw this out, the denotation carbon will be like this. So the outermost electron of carbon is what? Is 4. So it is this outermost electron of any element that take part in what? In chemical reaction. So I'll be dealing with this outermost electron. Let me distribute this according to what? Avbar's principle and Untrue. You what? I will what? Fill singly before pairing. So let me fill singly. 1, that's 1 electron for this 4. 2, 3, and 4. So organic chemistry is majorly about carbon. Please take note of that. It's all about carbon. So I have 4 electrons here. 1, 2, 3, 4. So let me look at the 4 electrons. Let me split it out here. 1, 2, 3, 4 for carbon. Alright. I haven't gotten that. Let me bring hydrogen. I'm attaching hydrogen to this carbon. So if I'm attaching hydrogen, the atomic number of hydrogen is what? Is 1. So that's hydrogen 1. So hydrogen will have only what? 1 electron. That's 1 electron. This is electron. I can put it here, I can put it here, I can put it here, I can put it here. Yeah, so if I put it here, I attach hydrogen. How many electrons has hydrogen? 1. So let me put the 1 hydrogen here. I attach another hydrogen. How many electrons? 1. Let me put the 1 electron here. I attach another hydrogen. How many electrons? 1. I shouldn't put it outside. Let me put it inside. So 1. The last one is I have the last hydrogen here. So this is carbon. Carbon is attached to how many hydrogen? 1, 2, 3, 4. 4 hydrogen. How many carbon atom are we having in this molecule? We are having just 1 carbon atom. So because it is 1 carbon atom, it is called what? Met. But we have all single bond. This is a single bond molecule. If it's a single bond, then it belongs to the alkane family. We are still coming that. We are still a representation of structures. We are representing structures. So the name of this molecule is what? Methane. That is methane. Carbon. 4 hydrogen. So if I want to write it structural, I can write it as CH4. C, 1 carbon, hydrogen 4. 4 hydrogen. That's CH4 for methane. Also, if I want to write this molecule, there's another way I can write this. And what is the second way I can write it? I can write it like this. In Lewis structure, 2 electrons like this between a particular element. 2 electrons between 2 elements is represented as one single line. So if I draw a single line and it means I'm talking about what? 2 electrons. So I can write this as what? Carbon. We have 2 electrons. This single line stands for what? The 2 electrons. I put my hydrogen. These 2 electrons I have hydrogen. These 2 electrons I have hydrogen. These 2 electrons I have what? Hydrogen. So that's the first way. I can represent methane this way, or I represent it as this. This single line stands for 2 electrons. 2 lines, 2, 2, 2, 2. That's that. Alright, let me try to take the carbon atoms to 3. Let me see how I represent it. That is, I'm talking about 3 carbon atoms. I told you 2 carbon atom stands for what? L. 3 carbon atom. Carbon atom stands for what? Probe. 4 carbon atom stands for what? Boot. 5 stands for pent. 6 stands for eggs. 7 stands for ept. 8 stands for ot. 9 stands for none. And 10 stands for deck. In the next class, I'll teach you 11, 12, 13, 14, 15, 16. They are very simple. Like 13 is trideck. 14 is quadrodeck. And so on. Like 15, 5. I'll just call it pent deck. And so on. So in the next class, I'll teach you. So mind you, let's come back to the class here. Let me take 3 carbon atoms and let me use 3 carbon atoms. That is 1, 2, 3. 3 carbon atoms. Normally carbon is attached to how many electrons? 4 outermost electrons. 1, 2, 3, 4. This carbon atom is attached to how many electrons? 4 again. Let me take this. It's not necessary I put 1, 2, 3, 4. Take away this. They are both sharing this. This carbon also, they are both sharing this. 1, 2, 3, 4. Let me attach the hydrogen. Hydrogen is 1 electron. That's 1. Another hydrogen is 1 electron. That's 1. Another hydrogen is 1 electron. That is what? Is 1. 1 hydrogen, 1 hydrogen, 1 electron for this hydrogen. This position has already been occupied by another carbon atom, so I don't need to attach any hydrogen to this middle. Let me go here. I can attach 1 hydrogen to this, 1 hydrogen to this, 1 hydrogen to this, 1 hydrogen to this, and the last hydrogen to this. So now let's look at it. 3 carbon atoms. How many hydrogen in total? 1, 2, 3, 4, 5, 6, 7, 8. So I can write this structurally as what? How many carbon atoms? 3 carbon atoms. That's C3, 3 carbon atom. How many hydrogen? 8 hydrogen. H hydrogen. H8. That's 8 hydrogen, 3 carbon atom. So if I don't want to write it this way, I can write it as what? Structurally, I can also write it as I told you. 2 electrons stands for what? A single line. Single stroke. So I have 3 carbon. 1, 2, 3. Alright. Sorry. This carbon is 4. This carbon is 4. Alright. Now let's go. Here to here, how many electrons do we have? We have 2 electrons, and 2 electrons stands for what? One singular. 1, 2 electrons, 1. So I think 2 electrons, 1 bond. Yes, 2 electrons, 1 bond. It's complete. We have 1 hydrogen for the 2. For here we have 2 electrons. So if we have 2 electrons here, I can denote it as what? As single bond. So we have 1. We have 1. We have 2 here. 2. We have another 2. 2. We have another 2. 2. We have another 2. 2. We have 2, and we have 2. Very simple. That is how to do what? To represent structures of organic molecules. In our next class, I will teach you how to represent using line angled diagram. Thank you for listening. Bye bye. Stay safe.